ENCOR Section 20 Summary Challenge. Multicast protocols. Which protocol does a receiver use to register their interest in multicast traffic at the first hop router? This is IGMP. IGMP stands for Internet Group Management Protocol. So PIM, DM, or PIM SM, these are protocols that or it's actually the same protocol with different modes, dense mode and sparse mode. These are used by routers to talk with each other to kind of set up and manage the flows of multicast traffic. Which protocol is a Cisco proprietary mechanism that permits backup RPs to be configured for failover? So this is AutoRP. AutoRP is a Cisco proprietary protocol or mechanism. In AutoRP, there is candidate RPs. They are routers which are configured as candidates to be rendezvous points. And RP overall here stands for rendezvous point. And they announce their willingness to become RP to a particular multicast address 224.0.139. And then there are RP mapping agents which listen for these, let's say, RP applications. And they kind of take them in, and then they advertise these applications on another multicast address of 239.0.140. And then all PIM-enabled routers, so routers enabled for multicast routing, they listen to this group .40, and they basically learn information about RPs this way. Okay. What is the scope and address range for multicast addresses that are reserved for use inside private domains? Okay, so they're in the whole domain, right? From 224.0.0.0 to 239, 255, there are basically three groups there, right? One group, the first class C or like /24 prefix, this is well-known addresses, and they are typically used for protocols such as OSPF or EIGRP, whatever, or some other purposes. And the rest of the space is for global use, right? And then another smaller space at the bottom, at the very end, is reserved for use inside private domains. And this is the last /24 network in the whole space, which will be 239.0.0.0, 239. Oh, is it 24? No, it's not /24. It's /8, right? I think it is /8. Okay. Yeah, I think it's /8. So this will be the local scope. This one, actually, they have indications here, and this is definitely local scope. What the question is talking about. The only thing to choose from is between these and these, right? And this is definitely not a good answer because this is what is well-known scope. Okay. And here, these two options are actually the same range, the same range of IP addresses, right? But I understand that I will need to choose the proper term, how it is called, right? What is the proper naming for this? And I think they are named in a way a bit weirdly that the well-known is called local scope. That's basically because they only operate within the local link, right? And what is actually reserved for private use is called administratively scoped, right? And it is indeed /8 prefix network 239 and everything within this prefix. So I hope this is correct. What are 3 important changes to IGMP version 1 that were implemented in IGMP version 2? Okay, so group-specific queries, membership reports, querier election mechanism, leave group message, stop group message, team-specific queries. There is definitely leave group message. I can clearly remember that. Then group-specific queries. No, I think group-specific queries were implemented even in IGMP version 1 because it's the whole point of the protocol is to indicate the group the receiver wants to join. Then query election mechanism. This is one more thing. And the way I understand that, if there are 2 or more routers available for a given local network, then there is probably some election will happen between these routers to elect who will be serving multicast traffic for a given group to this network. And one more thing which was added in version 2 is a leave group message. Yeah, I thought, yeah, okay. So leave group message is, I hope, correct answer. I don't really remember whether it's leave group or stop group. Probably it's just leave group. Maybe membership reports. Is this a thing? Membership reports. So I guess so, right? Because membership reports are sent by the hosts, by the clients to routers in response to a query or request from the routers. So I hope this is okay. Which IGMP version allows a host to indicate that they only want to receive traffic from a specific source within a multicast group? This is IGMP version 3 for sure. And this is just one, I guess, only one functionality which was added in version 3 on top of what existed before. So basically, the host can not only say, hey, I want to listen for this specific multicast group, but also I want to listen for this specific multicast group which is served by this specific source and indicate this unicast IP address of the source. And I think IGMP v4 is something which doesn't exist yet, or it's not mentioned in the course at all. There are 3 versions of IGMP which are discussed in the course. Which protocol is described in RFC 7761? Okay, and uses shared distribution trees rooted at the rendezvous point, but may switch to the source rooted distribution tree. Okay, I think this is PIM-SM, which stands for Protocol Independent Multicast Sparse Mode. So this is definitely multicast protocol, and only multicast protocol which is out there is PIM, right? So we should select between option 1 and option 3 over here. These are just distractors, I guess. And dense mode can only support the source trees, right? So there is no concept of rendezvous point with PIM dense mode, okay? And PIM dense mode is, as the course says, it's not much or not at all used in practice. So the answer is PIM sparse mode. And finally, which protocol uses a pool model enabling multicast traffic to be sent only where it is requested? It is again PIM-SM for kind of the same explanation, right? PIM-DM aggressively or forcefully pushes multicast traffic to all routers which are part of the multicast domain. And then these routers may say something like, hey, don't send this traffic to me. I actually do not need it, with what's it called, prune messages, right? And that's how dense mode operates. And PMSM actually does this in a different way. It does not even start to send traffic towards destinations which do not need it, right? It only starts sending when there is a receiver in a given branch of the multicast tree. Okay. There is one mistake. I will take a look and get back. Okay, as I expected, it wasn't question 4, and the mistake was related to IGMP, right? So what are 3 important changes introduced in IGMP version 2 over IGMP version 1? My initial answer was membership reports, and this is not correct because membership reports were there in IGMP version 1 from the very beginning, right? The idea is the router would send a query to all hosts on the network, to all computers, right? Asking, hey, which IGMP, which multicast groups you want to listen to, right? And they would respond. And and they would respond with these membership reports. So this is just there. It was there from the version 1 and used all over. What is this group-specific queries, which were actually introduced in IGMP version 2, and this is the correct answer here, that router can ask hosts, hey, who wants to listen for that group, right? So they can indicate the multicast group specifically, right? And send this query out to the computers on the network. And they would, of course, respond with their preferences, with their choices of, or with their indication of their willingness to listen to this or that, to this specific group, okay? And other options here are correct, and they were correct from the very beginning. Querier election mechanism, the querier is elected, and leave group message. So these 3 options are correct. I thought I'll give a little bit more explanation on this question as well. So this is about the scopes of multicast IP addresses. And I think really important thing to understand is that this scope, these names, they are not just names, they are not just terms associated with certain ranges of multicast class D IP addresses. What is a scope? Scope is an extent of validity or activity of something. In this case, it's IP address. So it makes total sense to have this specific naming, right? Local scope means that these addresses, they are valid or they are used within a local network, right? And this is correct in terms of the, for example, many routing protocols, as we know, they send their hello messages using some multicast addresses, but they always come within a direct link between routers, right? So these addresses are for the local scope, and this is the first class C or /24 range of the whole class D address space. So this is the correct range for the local scope. And this is not a correct range for the local scope, right? Then the biggest portion of the overall class D range is the global scope. And these addresses, they are valid globally, right? So they are routed across the public internet, right? And this is a correct indication of the address range for the global scope. And finally, there are administratively scoped addresses. So within our own internetwork, we decide basically as a network admin, as an organization, to which scope, to which extent these addresses will be used, which parts of the network will be using multicast, right? And to which parts of our network our multicast traffic will reach, right? And that's why it is called administratively scoped. And this is the correct indication of the address range for this